In this video, we're going to be talking about how to interpret motion using free body diagrams, how to understand what's actually going on in a free body diagram. So as a review, remember that free body diagrams show the individual forces that are acting on an object, but not the object's velocity. Any information about the object's velocity has to be provided in a word problem or in a dot diagram or some kind of table. The free body diagram does not tell you anything about an object's velocity. Also, free body diagrams reveal the net force that's acting on an object, which also reveals the object's acceleration. So this free body diagram has a net force to the right. The up and down forces balance out, and the rightward force is greater than the leftward force, and so the net force is to the right. And then finally, if you compare the net force to the velocity of the object, that reveals what's happening to the object. If the net force and velocity are in the same direction, it speeds up, for example. So, true or false, the object experiencing the forces shown in this free body diagram must be moving to the right. So what do you think? Is this object moving to the right? I'll give you a second to think about it. The answer is false. It's not necessarily moving to the right. It could be. The object is accelerating to the right, but it could be moving to the left or right. The velocity is not given. So remember, these diagrams are not showing anything about the velocity. It's all about the forces that are acting on the object. So as an example, this object shown in this free body diagram could be a car that's moving to the left, but has a parachute that's slowing it down. Okay, that would be an example of an object moving to the left, so it's got a little bit of an applied force to the left, but it's got a greater air resistance and it's slowing down. So it could be moving to the left, it could also be moving to the right. We're just not given that information. So for an object to be speeding up, there must be a net force pushing it in the same direction that it's already traveling in. So for example, if we look at these 5 options for free body diagrams, which one of these could be representing an object speeding up? Well, for objects that are speeding up and moving to the right, the only possible free body diagrams that match this would be the ones that have a net force to the right. So that would be that would be B and C. Those two have a net force to the right, and so that means they could be moving to the right and speeding up. But let's say the object was moving to the left. If it's moving to the left and speeding up, the only possible options would be free body diagrams that have a net force to the left. And in this case, that would only be A. So that's for objects that are speeding up. What if the object is slowing down? There must be a net force pushing it in the opposite direction if it's slowing down. So it's moving one way, but the net force is the other way. So which of these free body diagrams would work for an object that's slowing down? Well, it depends on which way the object is moving. If the object is moving to the right, but slowing down, then that means the net force would need to be to the left. So which of these has a net force to the left? The only one is A. If the object is actually moving to the left and slowing down, then that would mean if it's moving left and slowing down, the net force is to the right. So which of these has a net force to the right? B and C have a net force to the right because their rightward forces are stronger than the leftward forces. Lastly, for an object to be moving at a constant velocity, the forces must be balanced. If you remember Newton's first law, objects naturally move at constant speeds when forces are balanced. So we're looking for free body diagrams where the forces all balance out, and that object will be moving at a constant velocity. So which of these free body diagrams have the forces balanced in them? And the answer to that would be D and E. Therefore, in both D and E, the object is moving at a constant velocity, but we're not told which direction that velocity is in. We just know that it's a constant velocity. So let's practice with this one example here. Which of these free body diagrams could apply to the motion in the dot diagram? So if you look at the dot diagram, it's got an arrow above it that indicates which direction the object is moving in. And then it's got the dots representing how far it goes each second. So in the first second, it goes a little bit, then a little bit more the next second, more and more. So it's speeding up and it's moving to the right. So knowing that it's speeding up and that it's moving to the right means the net force must be pushing it further to the right. So the only options would be free body diagrams that have a net force to the right because it's speeding up and it's moving to the right. So the answer is, since the object is moving to the right and speeding up, any free body diagram with a net force to the right is a possible option. So in this case, that would be B and C. So I think that's all I've got for you in this video. So remember, happiness is not having what you want, it's wanting what you have.